Hello everyone, welcome to Ekeeda platform, and this is Ravindra Jangid here, your electrical faculty. And in this video, I'm going to talk about the numerical number 4, that is AC line voltage and the current. Now I'm going to talk about the numerical number 4. So let's start for reading. So if we start the question number 4, that is actually saying AC line voltage is 330 volt, 330 kilovolt, and the load, whatever load it means, it will be in the power, and that is 500 megawatt, and the power factor is actually given there, that is the 0.78. So that is the real power given, and it is along with the power factor, and it is actually given at the inverter end. So please, sometimes the question are actually framed according to the inverter end, or you can say the rectifier end. Now, so it is now actually saying that, so calculate the AC line voltage and the current and the power factor. So three things you have to find, but it should be on the rectifier end. So, but the some values are given which are actually defined as the mu 15 degree, R line is equal to 3 ohm, and the X rectifier is equal to 58 ohm. So these things are actually given. So it is pretty much easier. But before going to that, what kind of this mode? This mode is actually the mode number 1, where you go for the mu less than 60 degree. Because here the mu is actually given 15 degree, it means it is obviously going to be less than 60 degree. Now we will find the one by one. First we will find the different values which are actually going to be used in the rectifier side. So firstly find the different values. So let us start with this inverter end. So if I talk about the inverter end, then it is actually the IL, and we are finding actually the IL. So it is actually very easy, because in the power system we have already found, or we have already used these formulas. So you can say that the power upon root 3 VL cos phi, this is simplest formula we have used in the power system so many times. So here it will be 500, because of 500 megawatt given. So 500 into 10 raised to power 6 to root 3, 330 into 10 raised to power 3. 330 into 10 raised to power 3 from it came, and this is the VL. Okay, so you have to put the VL value here, and after putting the value, you are getting, and the power factor here, the cos phi, so put the cos phi here, that is the 0.78, put the 0.78 here, and after the simplification you are getting the 1121.5 ampere. Okay, so up to here we have already find the IL. Now we will use for the ID, that is the DC load current, and that is the ID, and which is actually its formula we have used so many times, that is ID is equal to pi upon root 6 IL. So if I talk about the pi upon root 6, so you have to put the value of the IL, and this is the value of the IL you have to put here. Now after the simplification, you are getting the 1438 ampere. This is 1438 ampere. Now we will find the VDI, that is the DC voltage on the inverter side. So what will be its value? The VDI upon ID only. So just put the value. So after putting this value, so this is the PDI, so load will be the same. This is the 500 megawatt. So put the 500 into 10 raised to power 6. Okay, I have written wrong. That should be the 10 raised to power 6, and after simplifying, once again ID, you have to put the ID, and that is a 1438 ampere, and you have found from the above step. Okay, and now after getting this, you are getting the 347.6 kilowatt. Just you have to calculate and put the values here. Now we will move for the rectifier. We have found the different values on the inverter side. Now we will move for the rectifier end, and what will be its values are going to be found here. Now if we move for the rectifier, then you have to use this formula. This is the simplest formula which I am using, that is a VDR, that is a rectifier side voltage, and this is the VDI plus IDR. Okay, so you have to just put the values here. So VDR, okay, rectifier side voltage, VDI you have already found. Okay, from where you have found this 347.6 kilovolt, just put the value, that is 347.6 kilovolt. So you have to put the values 10 raised to power 3 here, and then ID into R. What is the ID that you have found from this above one? That is a 1438. Okay, I have written this wrong again. 1438. So you have to put 1438, and the resistance is given, R line is given 3 ohm. So just put the values. After the simplification using the calculator, you are going to get the 352 kilovolt. So this thing you have to find, because this is the simplest thing, or maximum question can be framed from this, because the easiest to do conceptual and actually most probable chances of coming of these questions in the previous years also. Now, so if we talk about the VDR, so what is the VDR? We have talked about already, that is VD naught cos alpha minus 3 upon pi ID into XR. Okay, so now you have to put here the values, and then you will get the answer. Now after putting these values, as we have found the VDR 352 into 10 raised to power 3, and then this is the VD naught we have discussed so many times while deriving our derivations and doing the numericals previous. Okay, so 3 root 2 upon pi ELL. I have already used ELL. You can use the VL, ELL, both are same, because we have to use the line to line voltage. Then put the values of cos alpha, that is a cos 15 degree. After putting this value, you are going to get 3 upon pi. After going to get, we will solve, but I'm proceeding for that firstly. So minus 3 upon pi, that is written above, and put the value of ID. That is also going to be 39. And put the value XR, that is a 58. Okay, that is actually 38. So put here 38. One second. That is going to be 3, and it is going to be 8. So, and calculate these values, and you are going to get simplified, just rearrangement. So when you will rearrangement, then so you will going to get VL, and which is equal to 331 kilovolt. That is 331 into 10 raised to power 3 only, na? Now, so up to VDR and up to, or you can say the VL we have derived. Now we will find the output power at the rectifier. So what is the output power? Just you have to multiply the voltage and the current. Okay, so what is the voltage? 352 into 10 raised to power 3. That is the 352 here we have found. Now, so as we move for this, then and the current is 1439. You can 38 and 39 approximately are the same, so you can put there. And here I am also changing. Why I have done this mistake, don't know. So please put the values here, and you will get the answer 506.2 megawatt. After putting these values, as the voltage VL is almost same, then IL is going to be 1121.5 ampere. Okay, because both the sign, because it's PR is also the 506.2 megawatt, and it is also the at the inverter side, it is also the 500 megawatt. So there is actually very less difference if we talk about the megawatt values, because what happens, it is 10 raised to power 6. So I can clearly say that it is a small change as per their values. Okay, so 1121.5 ampere, and that is actually a value of IL. And I have compared the values, otherwise you can find from the formula also. Now, as both AC and the DC voltages are actually the same, then I can say the 506.2, and then VDC is equal to root 3. Okay, and once again, this is a PR is equal to 50.6. That is a VDC, and we will find the PAC. There's a root 3, and this is a 331 10 raised to power 3 and 1121 into cos phi. And likewise, you will get to know that a cos phi is going to be 0.787. Okay, I have written this values to here. So this is the basic numerical. Many times it has come, so please revise these formulas and the concept. So I hope you up to this you have understood. So tata, bye bye, and thank you.